Hi and welcome to another webinar. My name is Stace. I'm the technical evangelist at Varnish Software, and today we'll be talking about setting up, configuring and managing TLS in Varnish. And we'll be covering the full ecosystem, so we'll be talking about the past, the present and the future of TLS in Varnish Cache, but we'll also be looking at Varnish Enterprise. But first things first, what is TLS? Well, it's short for Transport Layer Security, and it's actually a protocol that is part of the network stack responsible for encrypting traffic between a client and a server. Now, you might think of SSL when you hear that definition, and SSL is short for Secure Socket Layer, and it's actually the predecessor of TLS. TLS is a more evolved version. And while it's all about security, of course, about the encryption, ensuring that your connection between a client and a server is safe, it's also about trust, because certificates that are used to sign these requests and to encrypt that traffic will, of course, need to be issued by someone who is trustworthy, a CA, a certificate authority. And they ensure that whoever uses a certificate is who he or she claims to be. And in our context, we tend to use TLS in conjunction with HTTP, and that results in HTTPS, the secure form of HTTP. But when we look at Varnish Cache, the open source project, historically, TLS, under the form of HTTPS, was never supported, not between the client and Varnish, nor between Varnish and the origin server. That required you to offload TLS elsewhere, and that's what we're going to talk about as well in this webinar. However, Varnish Enterprise, the commercial product developed by Varnish Software, by us, actually supports TLS both between the client and Varnish and between Varnish and the origin server. If you want to offload TLS, you'll need a TLS proxy. That's a piece of software or a device that sits in front of Varnish and that handles the TLS connection, decrypts it, does all the certificate stuff, and then talks in plain HTTP with Varnish. And there's plenty of options there. Of course, you have HAProxy, which is a very well-known and well-respected open source proxy server and load balancer. But there's different solutions out there. If you're using one of the big public cloud vendors, they have load balancers there, application level load balancers that can handle the TLS for you. You can also use Hitch, which is an open source project we developed ourselves at Varnish Software, or you can use web servers that also have proxying and TLS capabilities, such as an Nginx or an Apache. And if you have load balancing or offloading appliances in your network, in your rack, you pretty much can use those as well to offload the TLS. And of course, this is just a couple of items. There's a whole range of products, solutions, and projects you can use to offload TLS. And while Varnish doesn't support TLS natively, well, it does facilitate the offloading using the PROXY protocol. The PROXY protocol transports client connection information across multiple proxy servers. It's not a replacement for HTTP, it's just a preamble to the requested data. Let's illustrate how the PROXY protocol works using the following setup. So normally you'd have a Varnish sitting in front of your web server communicating with the client, but if you want to use HTTPS, we'll need a TLS proxy in front of it. For Varnish, which has IP address 10.10.10.3, of course, the original client is 10.10.10.1, but it's not necessarily aware of that without the proxy protocol because it only sees the TLS proxy as its direct client, so it knows IP address 10.10.10.2. Now, of course, there's protocol information there, so the client connects to the TLS proxy over HTTPS, which means using port 443. Varnish communicates with the TLS proxy over the proxy protocol, which we assigned port 84433 to. And of course, the communication between Varnish and the original web server is happening over port 80 over plain HTTP. Then you have the client ports as well thrown into the mix, and this information is also relevant. But when you look at it from a session point of view, the TCP session that is enabled between the TLS proxy and Varnish, it would seem as though the client is 10.10.10.2 coming from port 36670, which is the TLS proxy's client port, communicating with Varnish over port 8443 with IP address 10.10.10.3. Now, while that is the network connection established between the TLS proxy and Varnish, that doesn't represent all the client connection information between the original client and Varnish. And that's where the proxy protocol really excels, because it manages to transport that proxy header containing 10.10.10.1 over port 58076 as the client, and the server being 10.10.10.2 over port 443, which is the HTTPS connection that was established with the TLS proxy. There are two versions of the proxy protocol, V1 and obviously V2. V1 is a single line clear text protocol that is very basic. It starts with proxy and has different fields. It has as one of the first fields TCP4 or TCP6, whether you're using IPv4 or IPv6. It has the client IP, the server IP, the client port, and the server port. It does what it needs to do, but it's very limited in terms of features, and that's where proxy protocol v2 comes into play. Version 2 of the proxy protocol, the version that we recommend that you use, is actually in a binary format and has a lot more information. Of course, it has all the client and server ports and IP addresses, and while it supports IPv6 and IPv4, it does more. So yes, it supports TCP, but it also supports UDP and Unix domain sockets. And thanks to TLV attributes, it contains a lot more information about the TLS connection. If you want to support incoming traffic over the proxy protocol in Varnish, you need to configure an extra listening address in your Varnish D runtime configuration. While the typical port 80 is there to handle plain HTTP traffic, you need to define one that listens on port 8443. This is not a duplicate. This will not take plain HTTP. By adding the proxy argument, you're indicating that this is proxy traffic where the proxy preamble should be parsed by Varnish. And we're specifically using port 8443. The 443 bit stands for the fact that this is offloaded TLS traffic, and the 8 that we prepend in front of it means that it's still clear text. As mentioned earlier, v2 of the proxy protocol also supports Unix domain sockets, and so does Varnish. So if your Varnish instance is on the same machine as your TLS proxy, there's no need to communicate over TCP/IP. Unix domain sockets can be used instead. And while TCP/IP is very simple to set up and very straightforward, sometimes there might be performance bottlenecks when you operate at a certain scale. Unix domain sockets can take away that overhead. And in terms of configuration, it is very straightforward. You also specify an extra listening address to handle that proxy traffic, but instead of mentioning a port and potentially a host to bind on, you specify the path to the Unix domain socket. It is important that your TLS proxy is also configured to communicate over that same file. As an argument, of course, you mention proxy so that Varnish knows to deal with the proxy preamble, and then the remaining data refers to file system permissions. It refers to the user that you're going to use to communicate over that socket and the group, but also the file system mode. Once you're up and running and you've successfully linked your TLS proxy to Varnish using the proxy protocol, there's a whole lot of extra information available. You have the objects like client, server, remote, and local that you can use to retrieve IP information or port information or socket and endpoint information. And in a non-proxy setup, remote and client are one and the same, and local and server also one and the same. But once you start using the proxy protocol, this gets split up. So that means the client IP is actually the original client IP, and the server IP is the original IP of the server that the client connected to, while remote refers to the next hop, so Varnish is its client, and local refers to Varnish its own connection information. And even the X4 header automatically gets set to the original client IP. So if you pass it along to your web server, it doesn't reflect the next hop, which is not your client, but actually the original client. And there's a lot more information you can retrieve, and you can use this using a vmod. It's called vmod proxy, and it can look into those TLV attributes. So when we look at this VCL snippet, the first thing we do is we import the proxy vmod, and then we can use some of these functions under specific circumstances. VCL is unaware of what's happening in front of it, and if there is not an X-forwarded proto-header, meaning there is not a proxy server in front of it that speaks HTTP, there might be a pure TLS proxy in front of it that connects using the proxy protocol. If that is the case, we can use proxy is SSL to determine whether or not the original connection was made on port 443. If that is the case, we'll set the X-forwarded proto-header ourselves to HTTPS. If that's not the case, we'll stick with plain HTTP. And this X-forwarded proto-header will then be used to create cache variations and ensure that there's separate objects in the cache for HTTPS and HTTP, but it also gets sent to the original web server, which uses that value to create URLs either with HTTPS or without HTTPS. Of course, there's a lot more to the story than just using the proxy.isSSL function to figure out whether or not the connection was made over HTTP or HTTPS. There's a whole range of extra information that is reflected in the API of vmod proxy. So if you look at the list, you can extract the application level protocols that were used. So hinting whether or not the TLS proxy supports HTTP 1 or HTTP 2, then you can get some authority information. You can also get information about client certificates that were potentially used. And then as you can see, the list goes on and on and on. You can get the version that was used. You can get the cipher, the key information, the signatures, all of that. Up until now, I haven't gone into great detail about which TLS proxy to use and how to configure it. I would like to mention that if you already have a preferred TLS proxy, something you already have in your organization, by all means keep using it. But if you're looking for something that ticks all the boxes, I highly recommend Hitch. Hitch is an open source TLS proxy developed by us, by Varnish Software, and its website contains all the info you need. Go to hitch-tls.org and you'll find all the releases, the documentation, everything you need to know. You can download the source as well. If you want to install Hitch via packages, you'll find them in the same location where you find the Varnish packages. That's on packagecloud.io/Varnish Cache. And if you go to packagecloud.io/Varnish Cache/Hitch, you'll find all the packages for Red Hat-based systems and Debian-based systems there. I said it before and I'll repeat it again, Hitch ticks all the boxes and that is reflected in its capabilities. So yes, it supports both TCP and Unix domain sockets as you'd expect. And of course, proxy protocol v1 and v2 are supported. You can register multiple certificates that can be managed separately. And thanks to SNI, server name indication, the system can automatically detect which certificate to use based on the host name. TLS protocols and ciphers can be configured in great detail, and we even support OCSP stapling in Hitch to check whether or not a certificate has been revoked or not. Hitch's configuration happens in the hitch.conf file, which you can see here. It has different configuration parameters, such as the frontend, for example, that registers the listening address of the incoming request for Hitch. Obviously, that's going to be on port 443, which is the conventional HTTPS port. And then you have a bunch of other settings, such as, for example, the backend. This is the system that the TLS proxy needs to proxy the traffic to. That will be port 8443. Of course, because we already mentioned that earlier, incoming proxy traffic on Varnish happens on port 8443. In terms of certificate management, then we look at the pemdir config statement. That registers a directory in which the certificates are located. And thanks to the pemdir glop parameter, you can define glop parameters to match. So that means even though there's a bunch of files in the etc hitch cert.d folder, only fetch the ones and load them that have the pem extension. And if you want to load individual files, you can use the pem file directive for that. There's other stuff in there, like if you want to use HTTP2, I recommend that you enable ALPN protos and set HTTP2 as your main protocol and then HTTP 1.1 as a backup. And all of this, of course, relies on write proxy v2 to be on to have version 2 of the proxy protocol. And you already know what that will look like from a Varnish perspective. You need to register an additional listening address, preferably on port 8443 to handle that proxy traffic. But it could also be done over Unix domain sockets. And if you're choosing the latter, you need to adjust your Hitch configuration as well. So instead of just going for a TCP IP based backend that points to port 8443 on the loopback interface, or by mentioning the host of your Varnish server, you need to register the Unix domain socket. And just to be sure that the permissions are right, I highly recommend changing the group to Varnish so that it matches the group on which Varnish listens. Otherwise, you'll have issues communicating over that socket. And while Hitch is very secure and very fast, it could process more than 100 gigabits per second on a single instance, that didn't cut it for some of our clients. Some clients requested us to go beyond that 100 gigabits per second. And in our labs, we figured out that terminating TLS could form a bottleneck. That's why in 2020, Varnish Software decided to build in native TLS support in the core. That means no more TLS termination. TLS is handled natively within Varnish, but of course, only within the commercial product. To be perfectly honest, we didn't look that far when it came to the configuration of native TLS in Varnish software. We actually implemented a subset of Hitch's configuration directives, meaning you can take a full-blown Hitch configuration file, link it to Varnish Enterprise, and we'll use whatever we support. Everything else will just be ignored. That means that everything in regards to the process management or backend definitions or application level protocols, the proxy protocol, you can mention it there, we'll just ignore it. What I haven't mentioned earlier in Hitch's configuration is that you can define all the cryptographic parameters. You can define cipher suites and independent ciphers, TLS protos, ECDH curves, and the way cipher should be negotiated. All of that was supported in Hitch is also definitely supportive in native TLS. And how do you link that configuration file to Varnish Enterprise? Well, we invented a new runtime parameter called -uppercase-a, and it just links to that TLS file. It could be the hitch.conf, but we call it tls.cfg. It contains some basic parameters, and at the minimum you should mention on what port you want to listen, so you need a front-end definition and the location of your certificates. What's the performance gain, you ask? Well, we started out initially with 100 gigabits per second by using Hitch as our TLS proxy. By implementing TLS natively, we progressed from 100 gigabits to 200 gigabits per second. That's a pretty decent number. That dated back to 2020. But now we're much further along the process, and with tons of other optimizations in the core of Varnish Enterprise, we went from 200 to 500 and are now at a staggering 1.3 terabits per second of throughput on a single machine. And that is a world record. That was benchmarked by Intel on some pretty specific hardware. So I fully appreciate the fact that you probably won't need 1.3 terabits per second per machine, and I also understand that you might have difficulties acquiring some of that hardware. But the message is, Varnish is fast and TLS is very fast within the core of Varnish. If you use native TLS in Varnish Enterprise, you no longer perform proxying, so you don't really need vmod proxy anymore. But the capabilities of vmod proxy you need because you probably want to have information about the TLS connection. And that can be done now in Varnish Enterprise using vmod TLS, which replicated the functions to some extent. And as you can see here, you can use TLS is_TLS to figure out what the connection was like. Was it an HTTP connection? Was it an HTTPS connection? And that allows you to set the X-forwarded proto header, just like we did in the previous example of vmod proxy. But of course there's more, and the API is a bit more extensive. You can get the TLS version, cipher information, authority information, again ALPN, and some client certificate information. Alright, let's switch it up a bit. We've talked about TLS from a client perspective throughout this webinar, meaning that we only cared about the TLS connection between the client and Varnish. But you have TLS at the other side as well, backend TLS. And as I mentioned, Varnish Cache does not support that natively. So that's why in Varnish Enterprise we decided to add TLS support towards the backend to ensure that you have an end-to-end TLS encryption. And that can be done in VCL by adding an additional parameter to your backend definition. Of course, you switch the port to 443, but then you ensure that Varnish knows, or that VCL knows, that this is a TLS connection. So you put SSL to 1. But there's more parameters to tune. By default, SNI is enabled and the peer and the host are verified, but you can tweak those parameters. And all of this happens in your VCL file. While we're on the topic of different types of TLS in Varnish, let's throw client certificates into the mix. We're used to server certificates, where a server has a certificate that it presents to the client to show that it can be trusted. This is verified by the client with a CA to ensure that this is not a fraud. You can do it the other way around as well, by issuing a client certificate to the server, and the server then checks whether or not the client can be trusted. It's a form of authentication, if you will. If you do this bidirectionally, we call this concept mutual TLS, and that is supported by both native TLS and Varnish Enterprise, but also by Hitch, so open source users can use it. In Hitch, it's simply a matter of adding additional parameters. The client verify parameter defaults to none, but if you set it to require and you add a client verify CA that points to a valid CA certificate, you can actually check whether or not the client can be trusted. And of course, as mentioned, this can also be done in Varnish Enterprise. If your Varnish backend enforces a client certificate during the TLS connection, you can issue that client certificate in Varnish Enterprise through the -z runtime parameter. It takes a unique value, which is the unique identifier of that certificate in the system, and then a path to the client certificate. You can do that multiple times if you have multiple client certificates, and in your backend definition you have an additional .certificate property that refers to the unique identifier that you defined earlier. If you have multiple backends, you can refer to the multiple client certificates that were registered. If specifying client backend certificates through the -z parameter is not flexible enough for you, you can also do that using Varnish ADM. There's a command called backend.cert.load that allows you to do the same thing. It takes the name, the unique identifier of that certificate, in this case my cert, and then the location, the path towards the client certificate. And if you perform Varnish ADM backend.cert.list, you can see the list of certificates with their unique identifier, the path, and also the expiration date of the certificate. And then in the same way, you can define a .certificate parameter in your backend that refers to that certificate that was mentioned. If you want to discard certificates, it's simply a matter of calling Varnish ADM backend.cert.discard and mention the unique parameter. We're almost at the end of the webinar, and I'd like to thank you for bearing with me for so long. Before we end, I want to look at the future of TLS in Varnish. We covered the history and the current state, but in the future there's more things happening. From a Varnish Enterprise perspective, we're committed to making server certificates hot reloadable in the same way that backend client certificates are. Right now we're relying on hitch-alike syntax in that TLS configuration file, which is not very flexible because it requires reloading the Varnish servers before we can have new certificates. We want to do that in a similar fashion as backend client certificates by having a Varnish ADM command that allows us to hot reload certificates and to refer to them. So that's very much in the books. When it comes to Varnish Cache, there's nothing I really can confirm, but there is talk about a native TLS implementation for the open source version that cannot be confirmed yet, but some people in the community are looking at it. But for now, I recommend that you use Hitch because it ticks all the boxes, that you terminate TLS, and that you use the PROXY protocol if you're using Varnish Cache. Thank you for sticking around. I'll see you next time with yet another webinar.